Welcome to myprojectbazaar.com. Our product title is an area efficient high resolution resistor string DAC with a reverse ordering scheme for active matrix flat panel display data drivers ICs. Now we are going to discuss about our product abstract. So now our process main objective is digital to analog converters. To reduce the digital to analog converters areas, research has considered the various architecture such as the switched capacitive silenced digital to analog converters and current DAC and resistor-string ADC, the RR ADCs, and then the DAC embedded amplifiers. The DAC has a long digital to analog conversion time because n number of cycle class are recorded to convert n bit of digital codes, whereas the mismatch of the differential pair of the current impedance in the finite output of the impedance. The DAC and DAC converters with the embedded with the string DAC using the DAC embedded amplifiers, the second stage of the commonly used data drives ICs because of the high linearity and high uniformity the small areas. In our process, n bit of two-stage DAC including the n to m bit resistor string DAC. The resistor DAC and n bit of the DAC resistors embedded the amplifier of the connector in series, whereas the m is an integer and n is the greater than the m. The both process is the string process, the high resolution digital to analog converters to realize the accurate and external compensation of the scheme the sense of the various electro characteristics. In the transistor, the DAC process most of the data and the driver sizes in the chip area on the cost of the ICs. The DAC resolutions of the small area high resolutions DAC is record. They realize the high color depth and the lower cost amplifiers. Now we are going to discuss about our product flow diagrams. We are giving the 10-bit digital input data sets and the process the digital to analog converters determine according the resolution of the resistor DAC and DAC embedded amplifiers, and then we can consider the LSB and MSB segmentation process. In the segmentation process we can consider the DAC embedded amplifiers. At the same time the resolution of the exponential increase, the resolution increases. The database the LSB to MSB, the process segmentation periodically high bit by bit we get increased. The second bit DAC embedded amplifiers, the measurement of the data drivers IC include the RDAC analyzed and compared with those previous ones in this process. And then we go into the decoder architectures functions. We have considered the some 10-bit digital process. We have split the selection line process and we get the decoding the process. The decoding process we can use the architecture like mux processor. We can select the selection bit that will to one mux processor, and then two type of the mux processor. 32 is to 1 mux and then 4 is to 1 decoding the process. After with the decoding output we get the LSB data. We consider directly through the DAC port. The DAC process we can apply the Kelvin value divider. In the divider we can consider two type of string process. We consider the DAC process, the OR and string DAC process. We are consider two type of string. Two times we get the two string DACs. One process we are going to the OR DAC completed. After we get the string DAC process. The string process we are apply the some algorithm matrically the Kelvin values dividers. After sync register with the buffer conditions, after we getting the RDAC and the string DAC encoding the process, we schematically on the 3-bit of the RDAC and the reverse ordering scheme. The proposed the process RDAC select the two voltages of the among reference voltages The voltage is divided based on the final voltage and the occurring in the upper digital codes. And the selecting the decoding process with the MSU selections and the gateway the decoding process. After we get the process, we get the pure DAC process in the final voltage reference with the divided based the performance analyze. Now we are going to discuss about the process running procedure. We have designed the process in Tanner 2 to Tanner 13 versions. I have first of all I have designed the DAC the block wise. First we have designed the basic of the process in the digital Tanner controller with using the amplifier process. They are giving the architecture models, and then we implement the finally RDAC process and then uh, string DAC process. This is our DAC process and then string DAC process. Now we are going to the first cell process we have implement and then running. This is the setup simulation process. After we are using the transient Fourier analysis, we are giving some instruction set. Stop time 200 nanosecond and maximum time setups 1 nanoseconds. These all conditions we give the mandatory process. After we finish this process, we are going to the running process, and then automatically we open the power calculations process, the edit waveform viewer. This we split the, so we give the DAC digital input and digital voltage output process. So this is input and output of the voltage in the digital to analog converters. After we are going to this process, we are using the same setup model. We are analyzed the injection get finished. After we are going to the running the process, we get the same edit waveform. So this also voltage process. So we have digital to unnoticed the inverse process. We get the what are the process given the input, we get the output for the inverse process. That time this is the disable low pulse zeros, we will get the enable functions. This is the what are the give the input, the inverse mode of process output we get it. And then this is the DAC, and then RDAC process we are giving the running the process, we get the some voltage. This process we getting the voltage process, the digital to analog converters in the string ADAC process. We have designed the both RDAC process and then string DAC process. We can complete the process. We can compare the same both values in the DAC. How to compare the DAC to string DAC process. Thank you. Leaving our website.